Hello students, today we'll be discussing about Coulomb's law in vector form. Now in our previous video we have already talked about Coulomb's law. So in Coulomb's law, it told us that a force between two charges depends on the magnitude of the charges, whereas F directly proportional to the magnitude of the two charges, and it is inversely proportional to the square of the distance between them. So we got a relation which was F is equal to 1 by 4 pi epsilon naught q1 q2 by r square. So this Coulomb's law, he only told us about the magnitude. We were not aware about the direction. So what the vector form tells us is, it tells us about both the magnitude as well as direction. So in this topic today, we will be studying about the vector form of Coulomb's law. So moving forward to that, we will be considering three coordinates here, x, y, and z, having an origin O. Now suppose let's consider two charges. Let one charge be q1 at position A. Likewise, the other charge be q2 at position B. Now, the distance of charge q1 from the origin, let's say it is r1 vector. Likewise, the distance from origin to q2, let it be r2 vector. Now, suppose that both q1 and q2 are having the same charge. Suppose that q1 is positive and q2 is also positive, and we know that like charges, they normally repel each other. Now because of q1, q2 is experiencing a repulsive force which is opposite, right? Now let's denote that force with F is equal to on charge 2 due to charge 1. Likewise, because of charge 2, because of q2, q1 is also experiencing a repulsive force in this direction. So suppose that this force also, let it be F on charge 1 due to charge 2, right? Now coming back to the unit vector, the distance between the two charges, the unit vector, right? So let the unit vector from q1 to q2, let it be r1 2 cap. Likewise, the unit vector from q2 to q1, from q2 to q1, let it be r2 1. So let F12 be the force applied on charge q1 due to q2, and F21 vector be the force applied on charge q2 due to q1. Then for force F12, we can write it down as F force on charge q1 due to q2 is equal to 1 by 4 pi epsilon naught q1 q2 divided by the unit vector is pointing for charge q1, it is pointing from point 2 to point 1, which is this. So we have written r21 square and r21 cap. So this cap shows us the direction. So where r21 cap is a unit vector pointing from 2 to 1. Similarly, for force F21, we can write it down as 1 by 4 pi epsilon naught q1 q2, and for q2 the unit vector is pointing from 1 to 2, which is this. So r12 square r12 cap, which is showing us the direction. So here r12 cap is a unit vector pointing from 1 to 2. Now if you look at this unit vectors, you can see that both of them are equal but in opposite direction. So I can write down the equation as r12 cap is equal to minus of r21 cap, or vice versa, right? So if I take up equation number 1, so let's take up equation number 1 and substitute this value here. So I have F12 which is equal to 1 by 4 pi epsilon naught q1 q2. So wherever I see r21, I'll be replacing it with r minus of r12. So here I'm not writing down a minus sign because square, if we square up anything, it becomes a positive term. And then we have one more thing here, which is r cap 21. So in place of 21, I'll be writing down as minus of r12 cap. So keeping aside the minus sign, if you look at the other equation which is written here, it is exactly the carbon copy of this equation here. 1 by 4 pi epsilon naught q1 q2 r12 square r12 cap. So in place of this equation, I can write it down as this. So f12 vector is equal to minus, right? And since this and this is exactly the same, I can write it down as f21 cap, right? So from here, I can conclude that the Coulomb's law, it agrees with the Newton's third law because the forces are equal and opposite to each other.